In this tutorial, we aim to distribute calls from a provider to a PBX randomly across two anynode systems. We will then verify the correct operation of the request router in monitor mode. Additionally, we will demonstrate load balancing based on the CPU usage of the target systems and how to add additional target systems. For this purpose, we use a pre-configured setup with a provider node and a PBX node. In the diagram, multiple anynode target systems are configured with a request router on anynode SBC1. Only the initial SIP invite message is handled by the request router. By default, distribution is performed randomly. All subsequent call interactions in the SIP messages occur directly between the respective endpoints. Outgoing calls from the PBX to the provider do not pass through the request router. Prerequisites. You need anynode version 4.12.5 or higher. The remote party, in our example the provider, must ensure that it accepts SIP messages from all involved anynode systems. The provider should send all incoming calls only to the anynode system where the request router is configured. The request router will then handle the distribution of calls to the other anynode systems. Since any node with the request router handles the initial SIP invites to the anynode systems, incoming requests from the VoIP provider are first processed by the anynode with the request router and then potentially forwarded to secondary or other anynode systems. To ensure that other anynode systems accept SIP invites from the request router anynode, the IP address of the anynode with the request router must be added to the provider node's whitelist for all other anynode systems. For encrypted connections, the request router certificate must be included in the trusted peer certificates of the receiving node. In scenarios involving Microsoft Teams direct routing, note the following. The request router may receive calls from Teams and distribute them to the various anynode systems. Since connections will not only be established from Microsoft to the Teams node, but also from the request router, each Teams node must trust the request router's certificate. If subject alternative names, SANs, are used, the SAN of the request router must be included as well. If you are new to anynode, consider watching our tutorial video First Steps with anynode for guidance. Add request router. We start with a pre-configured node setup consisting of a VoIP provider and a PBX. This configuration is the same on each anynode instance. Now, we want to set up a request router for it. Begin in configuration mode. In the left menu under configuration, navigate to request router. Click on Add Request Router at the top. We will now configure the request router for the VoIP provider. The request router assistant will guide you through the configuration in a few steps. In the request router settings, you can choose whether the local target nodes for this request router are only on remote systems or if one of the target nodes is on this anynode instance. In our example, the local target node from the VoIP provider is also on the local anynode instance. Use the top option if all target nodes are on remote systems. Click Next. If a local target node is selected, the request router assistant will adopt the port settings from the node for the request router. In our example, the port settings are taken from the local VoIP provider node, which uses ports 5060 and 5061. These ports are where the provider sends the invite requests. Since the request router now uses these ports, the request router assistant must assign new ports to the provider node. The assistant may suggest new ports with an open lock symbol. Enter the new ports where the VoIP provider will now listen. The request router will later forward the invite requests to these ports. When setting up multiple request routers, it's advisable for better organization to increase the original port numbers by a scheme of 100. This is especially useful when you are configuring several request routers. Click Next. For FQDN, enter the hostname where the local provider node listens. In our example, this is the IP address of the network controller of the local provider node. The request router sends incoming calls to this node. The hostname or IP from this step, along with the port configuration from the previous step, will be used to create an entry for the local node in the routing targets in the next step. Click Next. In the routing targets section, the assistant has automatically added the first anynode target system to which the calls will be distributed, which is our local anynode system. From the port step, the assistant has entered the port, and from the hostname FQDN step, the hostname or IP address has been taken. Now, we want to add our second anynode target system for the request router to distribute calls. It's also possible to use more than 2 target systems for call distribution. Click Add. Click Edit to access additional input options. For hostname, enter the IP address of the second anynode instance. Use the port configured on the second anynode system for the corresponding node. If the second anynode contains a replicated configuration of this anynode, you must set the same port here that you configured for the node in the previous step. The provider node on the second anynode system listens on port 5062, so we enter port 5062 here. Click OK. Click OK again to return to the overview of target systems. Click Next. For name, you can enter any name for the request router. The assistant suggests a name. We recommend modifying the name to make it clear that it is the request router for the provider. Click Finish to complete the assistant. Use Commit to apply the settings permanently. You will now receive an overview of the request router settings. The assistant has already configured all the settings. The primary edge is the main interface of the request router that handles incoming SIP traffic. It is the primary connection point for SIP signaling in the initial recipient of the first SIP invite, before it is routed to either the first or second anynode system, or additional anynode systems. The forwarding then occurs through the secondary edge, where call distribution to the anynode instances takes place. The target systems to which the first SIP invite of an incoming call is distributed are entered in the transport connection in the secondary edge by the assistant. The request router does not modify the information in the contact header but forwards the packet with the information to the node. The node then no longer communicates with the request router but directly with the calling endpoint. Editing the whitelist on other anynode instances. Since anynode with the request router handles the initial SIP invites to the anynode systems, incoming requests from the VoIP provider are first processed by the anynode with the request router and then potentially forwarded to secondary or other anynode systems. To ensure that other anynode systems accept SIP invites from the request router anynode, the IP address of the anynode with the request router must be added to the provider node's whitelist for all other anynode systems. Navigate to the provider node. Click on the Media Negotiation object. In the Settings tab, scroll down to the Network Peer Whitelist selection field. If you are not yet using a whitelist here, select the provider's whitelist or create a new one by clicking the plus button. Click the pencil to edit the whitelist. In the Settings tab, locate the table with the whitelist entries. Use the Add button to include an additional entry. The Add Network Peer Assistant will open. Enter the IP address of the primary anynode, where the request router is running, in the hostname field. Click Finish. The table now includes the desired entry. Don't forget to click Commit to finalize and apply all changes. Setting up failover between target systems. If you have configured a random call distribution, you can set up failover between the target systems. With multiple target systems, the request router detects a failed target system using options packets and excludes it from call distribution. We recommend changing the default setting and configuring load balancing with failover. Navigate to the corresponding request router in the left menu. Click the pencil icon next to the transport connection under the secondary edge. You will then access the load balancing connection object, where you can see the target systems previously described. Open the padlock under General Properties to change the default settings. 3 different modes are available. Load balancing mode without failover, default uses the list of target systems and load groups to randomly determine the target for an outgoing session. There is no failover in this mode. Load balancing mode with failover divides the target systems into load groups based on their current load. A target system is randomly selected from the best available load group for the initial session setup. If this fails, all other systems in the same load group are tried. If those fail, progressively worse load groups are used for session setup. Sequential failover mode, a pure failover mode with no load balancing capabilities. Target systems are used in the order specified in the Target Systems table. The initial session setup is always attempted with the topmost available system in the table. If this fails, subsequent systems are used in the specified order. The lower switches for redirective SIP requests are present only due to the combined handling of incoming and outgoing calls in the load balancing transport connection object and are not relevant for outgoing calls. Select the second option, load balancing with failover, and confirm the change with commit. Dashboard check. The dashboard provides a quick way to verify the correct operational status of a request router configuration with the anynode target systems. Switch to monitor mode to perform this check. In the dashboard, check the primary edge state and secondary edge state under request router. Both should be set to operational. Hovering over the Transport Connections display shows the number of anynode systems currently experiencing low load, medium load, or high load. Click on the request router entry to view more details. Monitor the options packets display, which shows specific SIP messages exchanged to check the availability and status of the endpoint. In this case, the request router is successfully sending options packets to the target nodes through the secondary edge. Also, check the operational status of the transport connections, where the anynode target systems to which the calls are distributed are listed. You have now successfully configured random call distribution to 2 anynode systems with the request router. Call distribution based on CPU load with load reporting. In our example, we have initially set up random call distribution. Now, we will configure call distribution based on system load for the 2 anynode target systems. To ensure that the target systems can correctly report load in options packets to the request router, you need to activate the load reporting feature with 2 conditions on each anynode target system after completing the configuration. For load reporting, you must first create 2 conditions that will be set to true when the CPU on the anynode target system exceeds a predefined threshold. On the anynode target system, navigate to Conditions in the left menu. Click Add Condition. The Condition Assistant will open. In this case, you do not need to change the settings for the top operator, as you are only adding a single rule. The default value is AND, which means that all individual condition rules must be met. Click Add to include a new rule within the condition. Next, we add the first operand. The default value is object-based status value, which describes the status of currently configured objects, such as the number of node sessions. In our example, however, we want to use a global system value, specifically CPU load. Therefore, select the second option, module-based status value. Click Next. For module, select Resource Access, File Upload and Download. Since we want to monitor the CPU load, choose CPU load for status value. The fallback value is used when the system cannot determine the value. You need to provide a fallback value in this case. For the Resource Access, File Upload and Download module, let's use an example. To create a condition for CPU load greater than or equal to 70%, you would set the fallback value to 80% to ensure that the condition is met even if the system cannot determine the actual value. The condition rule is always a mathematical inequality or equation, depending on the operator set in the middle, with module, status value, and fallback value on one side and a constant value on the other. Click Next. For comparison operators for integer values, select the greater than or equal to symbol. Click Next. On the other side, set the operand type to constant value. Click Next. Enter 70 for the constant value. Click Finish to complete the assistant. You will now see an overview of the entered condition rule. Click Next. Enter CPU high as the name for the newly created condition to easily identify it later. Click Finish to complete the assistant. You will now see an overview of your rules entered. Here is a summary. The condition is met if the CPU load is greater than or equal to 70%. If the value cannot be determined, a load of 80% is assumed, and the condition will still be considered met. Now, we will add the second condition for medium CPU load. As described earlier, click Add Condition in the top menu. Repeat all the previous steps to add a condition for medium CPU load, entering 40% for constant value and 50% for fallback value. Then, name the condition CPU medium. Don't forget to finalize your entries by clicking Commit. Next, we will enable load reporting on the target system. Navigate to the provider node on the anynode target system and click on the SIP transport object. Open the Behavior tab. Unlock the section for load reporting. Enable load reporting. Select the previously created CPU medium condition for medium load condition. Select the previously created CPU high condition for high load condition. Click Commit. Repeat these steps on the other anynode target systems if they are not replicated from this system. Don't forget to finalize the configuration by clicking Commit. Add additional target systems. You can later add more anynode instances as target systems. In our example, we have already configured 2 anynode instances and now want to add a third instance. Navigate to the relevant request router in the left menu. Click the pencil icon next to the transport connection under the secondary edge. This will take you to the load balancing connection object. Go to the target systems listed under the Settings tab, where the calls from the request router are distributed. Click Add. You can configure additional load distribution options at this point. The options specify how certain parts of the SIP request IRI should be treated on redirection has no relevance for outbound load balancing requests. With Specify a load that is assumed when no load can be determined, you can set a predefined load for a target system if the current load cannot be determined with the options packets. This specifies the expected load level of the target system. Choose between low for a low system load, medium for a medium system load, and high for a high system load. If you want to configure load distribution based on system load and the load of the target system can be accurately transmitted in the options packets to the request router load balancer, you need to activate load reporting on the anynode target systems after completing the configuration. For more information, refer to the load reporting section. Under priority, you can set a priority level for the target system. This can be useful to determine how likely the system is to be considered in load distribution when no accurate load information is available, as anynode does not receive options packets. Targets are grouped by priority, with a lower number indicating higher priority. The range is from 0 to 65,535, with 0 being the highest priority. Targets with the highest priority are used as long as they are marked as available. Under weight, you can define a weighting factor that determines how the load is distributed among multiple target systems, especially when accurate load information is not available for one of the systems. The range is also from 0 to 65,535. The weighting factor determines how often a target is used within a group. For example, if one target has a weight of 80 and another has a weight of 20, the first target will receive 80% of the calls and the second target will receive 20%. Click the plus at the top under Select a transport connection that defines the path to the target system. In the Assistant, you can assign a name of your choice for the new transport connection and thus for the entry in the list of target systems. Use the IP address of the system you want to add as a target system. For clarity, adjust the name of the new target system to match the names of the existing target systems. Click Next. Under Type, there are two options for specifying the type of transport connection. Standard transport connection refers to the basic connection used for transporting SIP messages between two endpoints. Load balancing connection distributes SIP messages across multiple anynode instances to ensure load balancing, scalability, and high availability. In our example, we want to add just another anynode instance without load balancing, so select Standard Transport Connection. Click Next. Under Proxy Server, use the IP address of the third target system. We recommend using the Edit feature for assistance. Enter the IP address of the third anynode instance in the hostname field. Use the port configured for the corresponding node on the third anynode system. On the third anynode system, the provider node listens on port 5062. Click OK to finish the input assistance. Enable Send Options packets if you want to determine the load of the third anynode instance. Click Next. The registration menu item allows any node to manage SIP user registrations. This is especially important if any node acts as a registrar or forwards registration requests to other registrars. We do not need this feature for our example. Click Next. When integrating another target system, the asserted URI ensures that the identity of users and systems is transmitted and verified correctly and reliably. We do not need this feature for our example. Click Next. Under SIP node, select the existing request router for the provider, as it will use the new transport connection to also distribute calls to the third target system. Click Next. The Operational State Condition menu item allows for continuous monitoring of the status of any node target systems. Any node can determine if a target system is in maintenance mode or not. This information is crucial to ensure that SIP messages are only forwarded to functioning target systems. We do not need this feature for our example and can complete the wizard. Click Finish. You now have the option to review and adjust the load balancing settings described earlier. Click OK. The third anynode target system is now listed under Target Systems. If the new target system is not yet on the whitelist, anynode will notify you with a message. Confirm the entry in the list with Apply. Remember to finalize the changes by clicking Commit. Congratulations, you have reached the end of this tutorial and learned everything important about the request router.